Okay, welcome. Hello. Ni hao. That's all I know. It's the only word I know. Thank you for being here. I appreciate your time, letting me teach you for the next couple of minutes. I know this is kind of a strange setup, right? It's different from what you're used to with the groups, maybe, with all these people staring at us the whole time, but it's okay. It's different for me, too. I see we have girls in the front, right? Boys in the back. It's about what it would be like in America for me, too. So it's a nice setup for our classroom. But thank you again for welcoming me. I'm excited to do some learning with you today. To get started, I want to share with you one strategy that I will use with you. We're going to do some talking to each other, some moving around a little bit. And so if I need your attention back on me, I'll use this signal. I'll raise my hand like this, okay? And if you see my hand go up in the air, you can put your hands up in the air, and then everyone's attention will come back to me, okay? You want to try it? So if we're all working and you see me go like this, then perfect. And your friends will see your hands go in the air, and that will remind them to stop talking and to have your attention on me, okay? Perfect. To get into the math, we're going to start with a warm-up. It's like if you're about to run a race or do some sports, you might stretch to get warmed up, right? We're going to do the same thing, only we're going to warm up for our mathematics, okay? I'm going to have 4 questions up on the screen. I gave you some scrap paper and a pencil. I think the questions that are going to pop up on the screen will be questions that you can handle. You can do the work. It should be a review of things that you've done in the past, okay? So nothing brand new. This is just to remind you about things that you learned in the past that you will apply, that you will do for some of the work later today, okay? There's 4 questions, and I would like you to try these on your own, just individually, okay? We will share some answers in a few minutes, but first, just try it by yourself, okay? 4 questions, here they are. And as you work, I'm just going to walk around and notice what you're doing and probably say hello and ask how lunch was, that kind of stuff, okay? So here's the 4 questions. 1, 2, 3, and 4. You can do it on the scrap paper. You might not know the first one, but you can try. I'll stand up straight. I like those shoes. Cool shoes right here. Those Nikes. Woo. Good afternoon to the group in the front. How are you today? You have a good lunch? Yeah? Did you get some sleep last night? Yeah? So you're feeling rested? Yeah? Good. Thank you for your work today. Good guess. Try these problems on the scrap paper. See if you can solve those problems up there on the screen, please. Good job showing your work there instead of the calculator, right? You just do it on your own. Good idea. How's it going back here, guys? Everything good? The calculators for these problems, or did you just do it on your own? On your own? No need. Good. These are things that you've done already in the past? The review? Good. Perfect. Okay, maybe about 2 more minutes. Maybe 2 more minutes, and then we'll share some answers with each other. Thank you. Good job. Okay, 1 more minute to finish up your warm-up. 1 more minute, please. Okay, we will wrap up the warm-up. Wherever you are is fine. If you didn't quite finish, that's totally okay. No problem. Don't worry. But we'll wrap this up. Now, we're going to share out some of our answers to the warm-up problems. To do that, we're going to move around a little bit, okay? We're going to get up and we're going to move around a little bit. So in a minute here, I'll say go, and we're going to move. Here's what we're going to do. We have some space right down this aisle right here in between the desks, okay? And we're all going to line up in one big row in this space right here, okay? Now, to line up, let's see, we're going to use how spicy you like your food, okay? So, like you have Szechuan food, they have those little peppers, right? Like 5 peppers, means it's really hot, spicy, it burns your tongue. You need water or milk, right, to make it feel better. So if you like your food really, really spicy, really hot, 5 peppers, you can stand over here. Very, very hot. If you do not like your food very hot, if you like it mild, not very spicy at all, no peppers or maybe just 1 pepper, you'll be down here on this side of the line. So we have not very spicy to very, very spicy. I personally, I'm kind of in the middle somewhere. I don't mind spice, but that would be too hot for me, right? And that would be too mild for me, okay? So however you like your food, very spicy, not very spicy. And we're going to get in one big line, okay? Ready? Go. Very spicy down here. One big line this way. Yep, you can face me. One big line. Very spicy down there, yeah? Good. Not very spicy, no? Mild. Good. Now, this is a good lineup. We have our friends down here that you like really spicy food, yeah. Kind of in the middle, not bad, but mild over here. Okay. There's not a lot of space, but I think we can do this. So imagine this is the line right here. We're going to fold the line, right, to create some partners. So, my friend, that you like it really spicy, you're going to walk, maybe we could just scooch back just a little bit. I know there's not a lot of space, but it's okay. So, you're going to start and come this way, and you're going to match up all the way at the other end of the line with my friend that doesn't like it very spicy. So, like this line, we're going to fold the line to give yourself a partner face to face. So, you can start and walk all the way down here. I'll push these chairs in. So you can start and go all the way to the end, to the very, very end. Perfect. And then you'll stand right across from someone so that you can share some of these answers. Perfect. Perfect. Good. Fold the line. Yep. Perfect. I see some handshakes. You can greet your new partner. So you can slide this way a little bit so there's some more space. Sorry, we're cramped up here in this classroom. You can slide right down toward me so there's a little more space. Perfect. Can I have you move this way for me? Just to make some more space. Keep coming. Perfect. Great. Keep coming. A little further. Yeah. Good. Okay. So you have a new partner. Say hello to your partner. Maybe shake hands. If you don't know their name, you can say hi and share your names. Okay. Perfect. Now, to start off, I'll take the first question, right? How tall is Mr. Pratt? That's the first thing that people notice about me usually is my height. It doesn't matter if I'm in a kindergarten class or I'm with high school students. They all ask about how tall I am. They want to know if I can dunk. Maybe not in these shoes, but yes, I can dunk. But I don't have to jump very high. I'm so tall, right? So the answer to the first one is about 2 meters. I know, 2 meters. I saw a couple people wrote that down. It was good. I saw some correct answers on that one. 2 meters, pretty tall, right? Yep, I can't help it. First partner is right across from you, right? I'd like you to share your answer for number 2. I saw some of you brought your papers with you. I should have asked you to bring your papers with you so you had your answers. But compare your answers to number 2. See if you got the same answer as your partner. And if not, you can just talk about why or why not. See if you got something different. You can kind of talk through your answer and maybe how you solved it. Okay? So the people that are on this side of the line, yeah? These people, they're going to start the conversation. They can talk first. And just talk about the second question up there, 17 squared, and share your thoughts with your partner. Okay? Go for it. Good. Get the same answer? Yeah. I see a lot of heads nodding. Yeah. Same answer. Same answers here. Okay. Sounds like that was a quick one, right? This is something you probably did a couple years ago. This is just a review. Now, we folded the line, right? Now we need to slide the line. This is going to be tricky because we don't have a lot of space, but we can do it. So I would like this side of the line, that's everybody on this side, to move down 2 people. 2 people, so you have a new partner. These 2 people on the end, you're going to have to come back all the way to this side. So we're moving this way. You stay still. This side's sliding this way. Okay, yep. 2 people down. 1, 2. You have a new partner. 1, 2. 1, 2. Say hello. Hi. Nice to see you. Scooch down 2. 1, 2. Yep, perfect. Good. Say hello to your new partner. And this time we'll talk about the third question, question number 3, up here on the board. The square root of 361. Number 3. So you can talk to your partner about number 3. Ready, go. Talk to your partner about number 3. 19. Yeah. 19. Yep. Good. Same answers. It's too easy for you, right? Good. 19. Yeah. I see a lot of heads nodding. Yep. Everyone's in agreement. 19. Yep. Okay, last question. This is for number 4, and then we'll wrap up this warm-up. Let's have that back line over there. The back line. Slide. Let's see. How about 1 to the left? 1 to the left. So you'll have to go all the way to find a new partner. You'll have to go all the way to the end. 1 down, perfect. You have a new partner, your last partner. Say hello, thank you. Good. Scoot down 1. And then talk about the fourth question. The fourth question. Ready, go. Same answers. Positive or negative? Yeah, good. Plus, minus. Same answer? Yeah? Good. Same answers? 10 plus minus 10? Yep. 10. Good, good. 10? Same answers. Good. Let's try our attention signal right here. See my hand up? Yeah, good, good, good. All right, last thing. Say thank you to your partner, and then return to your seat.
Thank you.
Good job, good job. Perfect, perfect. And then you can have a seat. Good job. Well done. Thank you. Thank you. So that was an easy way to start the class, right? That was a review. These are things that you probably did last year, the year before. To square a number, it's nothing new, right? Take the square root, you can handle this. I saw a lot of good answers there for number 4, including positive or negative, plus minus 10. I saw a lot of students shaking heads like, yes, yes, I agree. I got the same thing. So we all had similar answers. If you had something different, you could have just talked with your partner about why you got something different, or you could have shown each other your work and seen where maybe someone made a mistake. But we didn't really have any of that because these questions were easy for you. So good start. That was our warm-up. And we'll keep it moving. There are basically 2 major topics that we're going to talk about today. The first is called the Pythagorean Theorem. Pythagorean Theorem. And then a little bit later we'll get into different trigonometric functions. But we're going to start for a few minutes with the Pythagorean Theorem. Okay? Does that look right up there? Pythagorean Theorem? Yeah, okay. So, one of my favorite things to do is to play golf. Golf, yes. Let's take a look, see if this works. Oh. Golf. Ooh. Yeah. You can clap if you want. It's beautiful. So it's one of my favorite things to do. I love to play golf. I play golf usually on the weekend. I play in a golf league. My friend who's sitting right over there, he's got a yellow tie on. His name is Mr. Champagne. Mr. Champagne is his last name, I know. Mr. Champagne. He's my golf partner. We play in a golf league together. We play a lot of golf together, okay? This is one of the courses that we play. This is a golf hole. I know it's a little tough to see, so I outlined it here for you so you can see it a little bit easier. Over here, maybe I'll just point over here. This is where you start the golf hole. It's called the tee box, okay? This is where you begin the hole, and the goal is to get the ball into the pin, the flagstick. You know golf, right? Yeah. So this hole is kind of funny because there's this big area of trees, this area right here, and there's a house. You can't really see it, but there's a house in there, right? So you could play this hole sort of 2 different ways. The way that I play the golf hole or the way that Mr. Champagne plays the golf hole, right? So I like to play it safe. I like to play it safe and take the normal route. So I tee off and I hit it to the end of the fairway, and then I hit another shot into the green. So I hit one shot and then I hit a second shot. Mr. Champagne, though, yeah, he's a risk taker. He hits the ball a long ways. He hits it very far. And so Mr. Champagne makes the choice to go from the tee box straight to the green. Right over the house. Yes. And we have played this golf course a lot of times together, and I have seen him hit that house. I know. Right off the roof of the house. So these are 2 different options that you can take to play this golf hole, right? Mr. Champagne's is risky, mine's a little bit more safe, okay? You can see that this forms a right triangle, yeah? A right triangle with the right angle down here. Right triangle. I put in some distances there to sort of help with our math, with our calculations. So Mr. Champagne hits it 150 meters, really far. I hit it 120 meters, not quite as far, but it's not too bad, okay? So it creates a right triangle for us. We can use the Pythagorean Theorem. We can use the Pythagorean Theorem to try to solve to see how far apart we are after our first tee shot, okay? So the Pythagorean Theorem is up there just as a reminder. The formula looks like this: a squared plus b squared equals c squared. I know from your warm-up that you're comfortable with this Pythagorean Theorem. I saw a lot of you working this out as you were working at the warm-up. So I don't think this will be too difficult for you. But I put the numbers in there just in case you needed them as a guide. So on your scrap piece of paper with your pencil, I'd like you to please try to find that red distance up there. How far apart are we after one golf shot? I sort of got you started there with the formula, and I'd like you to please try to find B, solve for B, to see how far apart we are after one golf shot. I think this is a review for most of you, but that's okay. A squared plus b squared equals c squared. Very good. Fast. Looks good. Nothing to it. Don't forget to label your answers, right? Is it 90 elephants or 90 flowers or 90 what? There you go. Good. Try the formula. A squared plus b squared equals c squared. Or you're using a diagram over there with your ruler. Yeah. Good idea. Okay. Maybe about 1 more minute to finish up this practice problem. A reminder of the Pythagorean Theorem. Good, 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 good. Don't forget to label your answer. 90 what? There you go. Good. You don't usually have a camera over your shoulder, do you? In math class? No? Surprise. Good. Looks like most students are finishing up this practice problem. Okay. Heads are nodding. Okay. So as I was walking around the room, I was taking a look over your shoulders, and I saw most students came up with 90, right? 90 meters. Great. 90 meters. I agree. That looks right to me. Now, to finish up this practice problem, we have a few different values, a few different numbers up here, and you solved for the red one that was 90, right? You have 120, you have 150, you have 90. Think about, I'd like you to write down a statement, okay? A true statement about this situation. This is like a real world example, right, about golf. You can write down anything that's true. Just anything that's true about this scenario. So think about the numbers that are up there and just write down a true statement on your scrap paper about this situation, about this problem. It can be anything. You can talk about Mr. Champagne if you want. Any true statement. Any true statement. So we're trying to connect our mathematics to our golf situation. It could be numbers, or it could just be a sentence. You could just write a sentence about this situation. Can I have you please pause, take a look right up here. I know that's kind of a strange question, right? To write a true statement. And maybe I'm not quite asking the question correctly. If you could put your pencils down, just take a look right up here for me, please. Look right up here. Yep. So let me give you one example to help your thinking, okay? Let me give you one example, because I see a lot of students writing down numbers, which is one option. Here's a true statement about this scenario. A true statement is, Mr. Champagne hits the golf ball a lot farther than Mr. Pratt. That's easy. That's a true statement, right? Mr. Champagne hits it farther than Mr. Pratt. Okay? So that can be a true statement, something like that. A quick sentence to summarize this problem. You could talk about the red distance, how it relates. You could talk about that house that's risking its windows getting broken. Any true statement. Hmm? Good. Maybe just about one more minute to finish this up. Just anything true about the scenario. Okay. I like that one. Okay. Is anyone brave enough to share their true statement with me and the whole group? Thank you. Go ahead. Oh, yeah.
Distance that Mr. Champagne has to hit is 150 meters.
Perfect. The distance that Mr. Champagne hits the ball is 150 meters. True statement. Very good. Anybody else like to share a true statement? My friend, you had your hand up? Sure.
I find in every isosceles triangle, we find two little sides like A and B. If A plus B, the result must be greater than the hypotenuse. Yes, if 120 plus 90 meters, it must greater than 150 meters.
So you're saying side A plus side B,
yes,
it's always greater than side C.
Yes.
Very good. Perfect. True statement. I like it. One more? Anybody else like to share their statement? Thank you. Yes. The microphone? Good.
The triangle's area is 10,800 square meters.
So you did some more math. Good. You found the area of the triangle. 1/2 base times height. You plugged in the numbers, and you got that answer. True statement. Very good. Thank you. So this is a refresher about the Pythagorean Theorem, right? Can you nod at me? You've used the Pythagorean Theorem before? Okay, wonderful. So thanks for those summary statements. Let's keep it moving then and talk about trigonometric functions, okay? Trigonometric functions. So I'm going to give you some information right now, so you don't really need your pencils at this time. I'm going to share with you some direct instruction. I'll probably stand in this area so that I can point at the screen over here, because my little laser pointer doesn't really look very good up there. So I'll just stand here. Okay, thinking about trigonometric functions, there's a lot of strange vocabulary words, right? There's 6 vocabulary words up here on the screen. In a minute, we'll talk about sine, cosine, and tangent. But we're going to focus for now on these 3 vocabulary terms on this right-hand side of the screen: opposite, adjacent, and hypotenuse. Yeah? Opposite, adjacent, and hypotenuse. Here's a triangle. This is a right triangle. I know it's a right triangle because of this little symbol in the corner. And we're going to first talk about those 3 words: hypotenuse, opposite, and adjacent. The hypotenuse is always across from the right angle in a right triangle. It's always the longest side of the triangle. If you want to take some notes, you can. So the hypotenuse is always the longest of the 3 side lengths of a triangle. To define the other 2 terms were adjacent and opposite. To think about those other 2 terms, we have to give ourselves an angle. So you see my little red line up there on angle A. We're going to use angle A to define our other 2 terms, opposite and adjacent. Opposite is across from the angle that we're using. So here's angle A. The side across from that is opposite. That's the opposite side in a right triangle. And then the last term, adjacent, is the other side that is part of the right the angle that we're looking at here, angle A. You know the hypotenuse already is the longest one, so the other one that's left is the adjacent side of this right triangle. So here's the 3 terms for this particular right triangle. The hypotenuse is always the longest one. In this triangle, AC, right? From A to C, AC is the hypotenuse. The opposite is across from the angle. That would be BC, from B to C. And then the adjacent is AB down the side to the right angle. So these 3 terms will help us define our trigonometric ratios. We'll use these words to help with the trigonometry here in a second. The way that students that I teach remember these ratios is by using the first letter from these different terms. So you can see I underlined the first letter up there of sine, cosine, tangent, opposite, adjacent, and hypotenuse. The word that we use to help remember these ratios, it looks like this. I'll say it first. It's called SOHCAHTOA. 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 So look, ka, toa. Good. Let's try it again. Ka, toa. SOHCAHTOA. Okay? Now, I'm using these first letters of these terms, and that's how we're going to remember these ratios. SOHCAHTOA. Okay? Let me explain it further. So, SOHCAHTOA, you can see it written at the top, right? SOHCAHTOA. Good. Sine is the first of the 3 trigonometric ratios that we'll talk about. Sine equals opposite over hypotenuse. Sine is opposite over hypotenuse. You can see the S and the O and the H, right? So, that's the first part of this word, so. Sine is opposite over hypotenuse, yeah? S-O-H, S-O-H. Okay? So, we're going to do ka and we're going to do toa next. But this is just so. Opposite over hypotenuse. Next, we'll do cosine, C-A-H, ka. Cosine equals adjacent over hypotenuse. That's that middle part of that funny word, SOHCAHTOA. Cosine is adjacent over hypotenuse. And I bet you can guess the last one for the tangent. It's the opposite side over the adjacent side. Toa. SOHCAHTOA. Oa. Right. So again, to review, The word is at the top. You can look over here with me. SOHCAHTOA. The sine is the opposite over hypotenuse. That's so. Ka is cosine, is adjacent over hypotenuse. And then the toa is the tangent, opposite over adjacent. SOHCAHTOA. SOHCAHTOA. It'll help you remember these trigonometric ratios. Now, here it is again as a picture. Back to that triangle that we looked at a minute ago. We're still using that same angle A up there on the top. You can see again the sine of angle A is so. So, the first part of that word, so, is opposite over hypotenuse. And then if we're using the side lengths, that would be the opposite, which is BC, down here at the bottom. And then the hypotenuse, which is AC over the top. So if we write it as a ratio, that's BC over AC. BC over AC, if it's written as a ratio. That's for sine. Yep. Again, here's cosine, same diagram. This is the middle part of that funny word, ka, C-A-H. Cosine, A and H. So cosine is adjacent over hypotenuse. If we wrote it as a fraction, we have AB over AC. AB on the left-hand side over AC, the hypotenuse. The last one is tangent. That's that TOA, OA at the end, opposite over adjacent. So that's BC over AB. Yeah. Real quick to review. Sine, so, cosine, ka, tangent, TOA. Right? Good. Let's try a practice problem, okay? Practice problem. This is kind of like the golf example. This is another sport, because I like sports. I like to play different sports. This question is about baseball. And here's the problem up here on the screen. On a baseball diamond, I'm going to go over here so you can see it. On a baseball diamond, that's what this picture is, the distance from one base to the next base, so from here to here, and from here to here, and from here to here, from here to here, the distance is always the same. It's 28 meters. Okay? A right triangle is formed, ABC, right? ABC is formed by using first base, second base, and third base. Yeah? ABC is a right triangle. Your task is to find the sine of angle C, which is over there at third base. You'll have to use everything that we've talked about so far today to help you try to solve that problem. I'd like you to start trying this problem by yourself, individually, by yourself, and in a couple minutes we'll let you share some answers with your group. So that's all I'm going to tell you, and I'm going to let you explore this problem on your own and see if you can get to the final question, which is finding the sine of angle C. See some students that are drawing diagrams to try to help solve this problem. That might be something to try. I see some students are using the letters, right? So like AB over BC or something like that. But I'd like you to try to use that number, the 28 meters, to help you actually get to a numerical answer, a number answer, not just the side lengths. go. We have just a couple of minutes left. So this might be a problem. If this was a normal math class, I might give you this to take home as homework and try to solve it on your own. I think we're running out of time here, so I'll just ask you to kind of pause right wherever you're at. I saw some people getting some equations down, thinking about it differently, drawing a diagram as a way to solve the problem. I'll just go really quickly over here on this whiteboard. The right triangle looks like this, ABC. If we know that this is 28, and if we know that this is 28, we could use the Pythagorean Theorem, right? 28 squared plus 28 squared equals C squared. We could do all that math and get an answer here for C. I'll call it just C like that. So then if I was looking for the sine of angle C, we know sine, so, OH, sine is opposite over hypotenuse, opposite over this hypotenuse. So that would be 28 over whatever that value was for C that we found using the Pythagorean theorem, right? It would be a number answer normally, but I didn't do the math in my head that fast for the side length C. So imagine a normal math class, right? I would leave you with this as homework. One other assignment I might ask you to do is to come up with a problem on your own. Think of your own example. Write your own problem and solve it, and then bring it back to class the next day. That's another thing that I might ask you to do in this lesson, which is kind of different maybe, to write your own math problem. Because to write your own problem and solve it, you really need to know how to do the math, right? Don't have to worry about that, but that's something that I might want to do. Last thing, exit slip. I'm going to give everybody a little Post-it note. This is our last thing. It'll just take about 2 minutes. On this tiny little Post-it note, I'm going to ask you to solve one quick problem. It's not as complicated as the baseball one. It'll go pretty quickly. And on your way out the door, we don't really have a door, but this would be like your ticket to go to leave the class. 1, 2, 3. Can you give one to everybody, please? I'd ask you on this little piece of Post-it paper to just try to quickly find the cosine of angle Y. And then when you're done, when you find the cosine of angle Y, I would ask you to put it up here on this board like this. Slap it up there on the board, and then you can leave the class. That's like your ticket, like an exit ticket, okay? And this is our last. It'll take about 2 minutes, and then we're done with class. Thank you, thank you, thank you. So if you find a solution, this one might go quickly. If you find a solution, you can put your Post-it note up here, and then you can exit our classroom. Nice job. Do a handshake? Nice job. Thank you. Do knuckles like this? Fist bump? Good job. Thank you. Good job. Good job. Put your answers up here on the board, and then we'll wrap up our class. Good. Nice job today. Thank you. Very good. It's great. Thank you. All right. As you leave the class, I'm going to take a look at these answers, and I'm going to put the ones, some together. Yep. Very good. That's it for today, class. Thank you very much. Have a good afternoon. Enjoy your time. You can take those rulers with you. You can take the rulers with you. This is a gift. You can take this with you. Yeah. Take the pencils. Take the rulers.